All right, so now let's build a specific machine. And with the people around you, if you'd like, let's draw a state diagram for a DFA, deterministic finite automaton, over the alphabet AB. And we want the set of strings that are each accepted by this machine to be the set of all strings that have AB as a substring, so that's familiar from before, at the same time as being of even length. And remember that it's helpful to label the states with their roles in the computation as we process the input symbols. All right, let's come together and let's draw this diagram together. And I'm going to use Flap.js to draw it. My stylus has gone missing, so I can't annotate the slides today. But this way we'll see the diagram and also have a chance to play with a tool that will help us test our machines as well. OK, so in Flap.js, we're going to write down, just like we would on pen and paper, the states and then draw the edges between them. And when we're thinking of this pattern of we want to notice if the substring AB occurs in the sequence of symbols that we've read, but we also want to keep track of the length somehow, then in the first state, because we always have to start somewhere, so in the start state, we can imagine the role being that so far, I haven't made any progress towards seeing the pattern AB. So Q0 means no progress yet. But I also have to remember how long a string I've read so far. And if I'm in Q0 at the very start, I've read 0 many symbols. Is that an even length or an odd length? Even. So no progress yet, and I've read an even number of symbols so far. Okay? So now I have to think about what are my outgoing transitions from each state that I put in based on the possible input symbols. Because in a DFA, we need exactly as many outgoing transitions from each state as there are symbols in our alphabet. So I have to think about what happens if I read an A and what happens if I read a B. And if I read an A, well, then all of a sudden I've made some progress. So come back here. I'll go in edit mode, and then I can have a transition. And if I read an A, Q1 is recording the fact that the last symbol I saw was an A, and I haven't seen the full subscript yet. So that's the progress I've made towards detecting the substring. But then I also want to record what's important about length, because in this particular language, the parity of the number of symbols I've read so far is important. So my length so far in Q1, odd or even? Odd, because I've read one symbol, that A. OK. Now I also have to think about what happens if I read a B. And in that case, I haven't made any progress towards seeing the substring AB. So no progress. And the length of the number of symbols that I've seen so far is odd. So in a sense, Q2 and Q0, hold on. Come here, go there. Q0 and Q2 are playing a sort of similar role in terms of detecting the pattern of the substring. Both of them indicate that I haven't seen any of AB yet. Okay? If I'm in this state of having not seen any of AB yet, and I read a B, then now it's almost like I'm at the beginning again, because I haven't made any progress towards seeing that substring, and I'm back to having even length right now. Okay. But if I see an A, well, now I've made some progress, so should I do this? No, what's wrong with that? The parity is wrong. So I need to have another state which is going to record that I've made some progress. Here, I'll move this head of the arrow back here. And I've made some progress towards the the pattern that I'm looking for, that substring, and my parity right now is being even. Okay. So Q3, the last symbol I read was an A and not a B yet. I haven't seen that substring yet. And if I'm in Q3, then that means that the number of symbols that I've read so far is even. Okay. So now we've got 4 states in our machine. 2 of them, Q0 and Q2, have specified all of the outgoing arrows. But now we need to specify the outgoing arrows for Q1 and Q3. So we use our shorthand here for their roles to help us figure out where the outgoing transitions should be. So if we're in Q1 and we read an A, where ought we be? I think we're in the middle of the room now. Yeah, go for it, Daniel. Q3, cool, because the last symbol that we just read was an A, but now we've switched the parity of the length of the number of symbols that we've seen so far. So if we're in Q1, we read an A, we go to Q3. What if we read a B and we'll stay in the middle? If we're in Q1 and we read a B. Yeah, we should be somewhere happy. We should be somewhere where we accept a string if it brought us to this point. And all of these 4 states so far are not going to be accept states because none of them have detected that pattern that we're curious about. So that tells us that we need a new state. So we can have a state here. Actually, let me bring it back up because it was on that line with Q4. If we're in Q4 and we read a B, then now if we're in Q1 and we read a B, we go to Q4, and that's going to be an accept state. And the role that we're thinking of for Q4 is that happy place where we've seen the AB substring and the number of symbols that we've read is even. Okay. Go for it. Oh, great question. So when we look at the definition of this language, are we looking at an or of the 2 conditions or an and of the 2 conditions? And the definition here is an and. At the bottom of the worksheet, we're dealing with or, and we'll think about that as well. You're just a step ahead of us, so we'll get there. Thank you. All right. So Q4 is our happy state there. And now we want to think about the outgoing transitions from Q3 and Q4. So every time we add a new state, we're committing ourselves to exploring the outgoing transitions from that state. So let's, in Q3, so we've last saw an A, and we're in an even number of symbols that we've read so far. What happens if we see an A at this point? Where should we go? And now we're in that side of the room. To Q1, great, because that means that we last saw an A, and now we've got an odd number of symbols. And if we see a B, stay here. Yeah, go for it, Marie. Yeah, we want to make a new state, because in Q5, we're recording the fact that we saw the substring AB. We're not going to accept strings for which the computation of the machine on the string leads us to Q5, because in Q5, even though we saw AB, the number of strings that we've seen, the number of symbols that we've read up until this point is odd. But it's important to record the fact that we saw the substring, and so we have the transition here. Because at this point, if we're in Q5 and we read an A, where should we go? We're back to that part of the room. Q5 and we read an A, where are we going to go? To Q4, cool. Because at that point, if we read another symbol, and previously we read an odd number of symbols, then now we're going to read an even number. And we've already seen the substring, so we don't care if the symbol that we read right now is an A or a B. So actually, this transition is going to be the transition we make in either case. Either A or B will bring us from Q5 to Q4. Because at this point, once our computation is either in state Q4 or Q5, all we really care about from now on is the parity of the length of the symbols of strings that we've read. And so we can just bounce between Q4 and Q5 as we read a new symbol, because then the parity is going to be changing odd, even, even, odd, etc. And depending on where we end up at the end is going to be whether we accept or reject.